Okay, before we start the class, does anyone have any questions? You guys might have had a good amount of time to revise through the concepts, go through different videos again and again. Does anyone have any questions with respect to any concept, logic, or understanding?
Yes, sir. Sir, related to that, I'm stuck with that one hot encoding thing.
Mhm.
So I understood why are we doing it, but suppose after I have selected my features, say suppose the question is to predict the car sales is the question, sales of a car, and out of that I have color of the car, a price, and model of the car as my feature selected finally. अब इसमें
Okay.
से color is my category. So
Yes.
now I am one hot encoding it.
ठीक है.
So there are red, black, and gray cars. So I've one hot encoded it. So now my feature becomes red, black, and gray also, right?
You
Red,
are-
black, and gray
Yes.
becomes my feature. So now
Yes.
if I want to know कि इन तीनों में से भी which is the most significant color, which is having an impact on the sales, तो वो कैसे करेंगे?
So आपको ये जो जानना है, ये आपको मॉडल के थ्रू जानना है.
Yes.
देन आप एक बाकी सारा डेटा सेम रखिए और एक बार कलर ब्लैक डालिए, एक बार ग्रे डालिए, एक बार रेड डालिए, आपको डिफरेंस पता चल जाएगा.
अच्छा, सो मतलब वो पी वैल्यू से हम ये नहीं पता कर पाएंगे.
वैल्यू से भी आप पता कर सकते हो, बट देन वो मॉडल से नहीं पता हो रहा है, वो एनालिसिस कर रहे हो आप. पी वैल्यू एक स्टैटिस्टिकल वैल्यू एनालिसिस कर रहा है ना, तो वो पी वैल्यू से भी पता चलेगा. स्मॉलर
तो
द पी वैल्यू.
सो माय डाउट इज अभी रेड, ब्लैक और ग्रे तो अभी एक फीचर बन गया ना, नाउ दे आर फीचर्स.
या
So I can directly put them in the model, no? I can put
यस,
those features.
यस यू विल. आई मीन
हाँ.
आपको डालना ही पड़ेगा, वरना कैटेगोरिकल ट्रांसफॉर्मेशन का तो ऑब्जेक्टिव मीट नहीं होगा ना. Why are we doing
Okay.
categorical transformation? Because we cannot pass categorical data to the model. तो आपको
Okay.
कैटेगोरिकल ट्रांसफॉर्मेशन करके तीन नए कॉलम्स मिले, रेड, ग्रीन, ब्लैक, व्हाटएवर द कलर्स आर. देन यू
Okay.
ट्रेन द मॉडल ऑन दैट न्यू डेटा, द न्यू ट्रांसफॉर्म डेटा.
And out of that, will I come to know which is more significant?
By using the p value, feature elimination techniques, feature selection techniques.
अच्छा, अभी एक ही में अगर दो कैटेगरी है, जैसे मेरा कलर हो गया एंड सपोज टाइप ऑफ कार हो गया. So then if I do one hot encoding, so how will the model differentiate between which one and this one?
कॉलम अलग अलग हो गए ना, नए फीचर्स. So one category created 3 new features, another category might create 4 new features. Ultimately you had 2 categorical columns, now you have
Uh-huh.
7 columns, new columns.
7 you go, but that those one row will have many ones, no, in that.
Yeah, it will.
So but so then how will it differentiate ये one किस कौन से कैटेगरी का है?
उसको पोजीशन पता है ना.
Okay.
I mean, okay, let me try. You had this, right? इसके अंदर एक कैटेगोरिकल कॉलम था ये ब्लू वाला, और एक कैटेगोरिकल कॉलम था ये ग्रीन वाला. ठीक है. नाउ व्हाट एम आई सेइंग कि दिस पर्टिकुलर green column becomes 5 columns now, assuming, and this blue column becomes 3 columns now. ठीक है. But these columns have their own names, right?
Yes.
The model is going to treat this new column as just an individual column. मॉडल को थोड़ी ये पता है कि ये कैटेगोरिकल कॉलम से डिराइव हुए. मॉडल के हिसाब से इट इज जस्ट अनदर कॉलम दैट कुड हैव एग्जिस्टेड एनीवेयर इन द डेटा.
Okay.
Right? So number of ones should all actually be more than 0. Like एक ही रो में मल्टीपल टाइम्स 1 आएगा, बट वो 1 का एक पोजीशन है ना कॉलम से रिलेटेड. एक मॉडल जानता है कि आप सपोज आप एक ऐसे नॉर्मल चीज सोचिए, आप एज कॉलम में कोई वैल्यू पास कर रहे हैं, मॉडल को नहीं पता है ना कि वो एज कॉलम क्या है. मॉडल को पता है कि एज कॉलम का जो वैल्यू है उससे प्रेडिक्शन कैसे होती है. तो एज कॉलम का वैल्यू का जो पोजीशन है वो डेटा में 3rd नंबर इनपुट आता है या 10th नंबर इनपुट आता है, मॉडल को वो पता है. If you pass this as an array 1, 2, 3, and if you pass another array 4, 5, 6, model knows that it is going to compare 4 with 1, 5 with 2, and 6 with 3. Is that clear?
Yeah. Okay.
पोजिशनिंग है ना, हर एक एरे का एक इंडेक्स है, एक पोजीशन है, तो मॉडल नोस कि कौन से इंडेक्स पे कौन सा वैल्यू आएगा तो उसको कैसे रिएक्ट करना है.
Okay. Right.
You will have to do categorical transformation for all categorical columns.
Yep.
No matter how many there are. Either you can drop the categorical column or you have to do transformation. Because with categorical data, models cannot be trained.
Okay. And the original categorical column gets dropped, and now the transformed one comes into the picture.
Yes.
Yeah. Okay.
Okay. Any other questions from the group? Okay. I hope train test split was clear to everyone. Guys online, train test split. Train test split
Yes.
सबको clear था, right? I'll just load the data frame once. Okay. So now we've done one kind of processing called the categorical transformation. Now we'll look at another type of processing called the standardization or normalization of data. Yes, Pranavi, go ahead.
Yeah, sir. I wanted to understand that violin chart.
While
How
okay.
huh.
So it tells you the distribution. This is the minimum and the maximum, right? This is the central point. It tells
Okay.
you what is the distribution across this central point. Like you see this, more values are towards the lower side. You see this, more values are towards the center. Right? This is a very equal distribution, uniform distribution. Right? इसमें आप देखोगे तो the peak is very high. Okay? इसमें आप देखोगे तो distribution में पहले थोड़ा increase है, then there is a curve, then there is further increase. So your violin plot just tells you, जैसे age है, right? So age का minimum value कुछ है, age का maximum value कुछ है. अब age का distribution ऐसा है कि there are a lot of people in the age group, this one, 20 to 40. Then post 40, there is a drop. There are a few number of members who are post 40. Again, there is a slight increase in 45 to 50 range, and then there is a decrease towards the higher ages. So this is basically the distribution, frequency distribution. And then there is the minimum, maximum, mean, median, mode, 25 percentile, 75 percentile, etc. Okay.
Okay.
Right. I mean, यहाँ पे क्या हो रहा है ना कि ये एक इसका एक फिक्स्ड लेंथ है, राइट? बॉक्स प्लॉट में. Violin plot में instead of this fixed length, it is finding out the distribution in this area. That's it. Any other questions? So basically, violin plot is a combination of your frequency distribution plot. Right? This was your frequency distribution plot. Looked something like this. How is the data distributed in the range? And then you have your box plot, which gives you mean, median, mode. I mean, mean, 25 percentile, 75 percentile, median, etc., etc. So it combines this with the frequency distribution chart to give you the violin plot. Okay, which we just saw. Any other questions? Anyone? Okay. We stopped here, right? Standardization, normalization of data. Did we discuss this? Guys online, does anyone remember? We did not discuss this, right? What happened? Why is there nobody is vocal? What happened other than Pranavi? Nobody is responding. You see, there's a lot of you. Guys, can we proceed? Everyone. Riddhi, Sudeep, Moshami, Pratim, Moparna, Madhura, Indrani, Ifra, all of you. You can start, right? I mean, why is the group a little silent today? Cool. So let's start. Standardization of data. Now, this is another pre-processing step before predictive modeling, right? Why do we need this processing, this pre-processing? To bring data to a common scale to facilitate numerical comparisons. Okay, let me start with a simple example. Difference of age of 1 year and difference of height of 1 centimeter. Are these two going to impact, let's say, the health of a person equally? Think about it. Why not? Why not? Too little change for height, not too little change for age. Okay, let's consider 5 years and 5 centimeters. Now, 5 centimeter height will not create that much impact, but 5-year age difference will create a definite impact. Yes or no? Right? So the idea is the computer does not know, or the models do not know, that 5 units of age and 5 units of height are not the same. For the model, 5 is a number, right? Take another example, age gap of 5 years and salary gap of 5 rupees. Now, does everyone understand? Yes or no? The relative strength of variation in these two different columns do not have equal impact. 5 years of age gap is a huge age gap. 5 rupees of salary gap is not significant at all. Why can we humans understand this? Because we know the possible range of age, right? And we know the possible range of salary. Does everyone understand that? Yes or no? Yeah. So that the models are capable of understanding relative differences between data points, we want to bring everything to a common scale, right? For an example, there are a lot of exams that actually happen, out of 400 marks or 800 marks, right? But in the end, we do not look at absolute numbers. We look at percentages. Does everyone understand that? ICSC or CBSC may, CBSC might have 2 extra papers. ICSC might have 1 less paper. But when we compare ICSC and CBSE student, we talk about the percentage that they got. Why? Because percentage is a common ground to compare performance. Am I clear to everyone? That is the process of scaling or standardization or normalization, right? Different words, same idea. We want to bring our data into a common scale so that we can compare numerical values. How do we do that? Let's say the common scale I want to bring my data is in 0 to 1. Okay. How can I bring my values in 0 to 1? Suppose my age ranges from 30 to 85. This is the range of my age column data. Okay. What will I do? Every age data point that I have, I am going to apply this transformation. Age minus minimum age divided by maximum age minus minimum age. Okay. Suppose my age in the data set in this range is 45. What will 45 become now? 45, which is the age value, minus the minimum value, which is 30, divided by maximum 85, minimum again 30. This calculation is always going to give me a value between 0 and 1. Can you tell me why? This calculation, this formula will always give me a value between 0 and 1. Can you tell me why?
Because that is the range.
Yeah, because what is the maximum value of age? 85. If I put 85 here, so 85 minus 30 divided by 85 minus 30, which will give me 1. What is the minimum value of age? 30. 30 minus 30 is 0. So I will get minimum value 0. The possible value is now 0 to 1. Now, this particular value also incorporates the maximum and minimum value. So this can be applied to all numerical columns and all of them can be brought down to a common scale of 0 to 1. Is that understood logically and theoretically? Everyone? Any questions here? Right? So why do we do scaling? We already know that, so that the model can compare relative performances, not absolute ones, because absolutes can have different scales. And how do we do that? By applying strategies like min-max scaling. Okay. There are other strategies also. For example, there is standard scaler. What does it do? It takes every value, subtracts the mean value from it, and divides that by standard deviation of the distribution. Okay, this is also a form of scaling. It will bring everything to a common scale, right? Although it will not bring to a very restrictive scale like 0 to 1, right? But this kind of scaling will actually transform the distribution to a normal distribution curve. And normal distribution is the assumption of a lot of models. So if you convert your numerical data into standard scaling, which is basically going to convert your data distribution into normal distribution, then a lot of models will perform better on your data. Right? Now let me take you guys through an understanding of what is called a pipeline. Okay? Abhi, when you are training your model on some data, that data has gone through a lot of processing. You have done categorical data handling, you've done outlier removal, you've done scaling, all kinds of processing that has to happen to the data before the data goes into training. That process is called the transformation process from raw data to machine suitable data. Now, this particular transformation has to be applied to every new data point that comes to me. Yes or no? Now, if the user wants to make a prediction, because my machine learning model or my predictive model has seen data in a particular format, I have to transform my new raw data into that same format. Right? So the pipeline acts as an automation tool for what processes do you apply on new raw data to convert it into machine suitable or model suitable format. Is that clear, everyone? Any questions so far? Okay. So the idea is that whatever data I get, I am going to transform it by applying multiple functions. Now, one variation is certain functions are going to apply to certain data types. For example, categorical transformation, I don't want to apply it on numerical data. Does everyone understand that? Yes or no? Right? So I am going to use scikit-learn's make column transformer. This is basically an element of a pipeline where I can pass it the function that I want to apply and the columns that I want to apply that function to. Then post this gets executed, what is the next function that I want to apply and the column that I want to apply it to. Remainder is equal to pass through means at every step, whatever columns I am doing the processing on, I want to make sure that the remaining columns stay intact. When I'm doing the processing on categorical columns, I want the numerical columns to pass through the pipeline without any changes. When I'm making changes to the numerical column, I want the categorical columns to pass through the pipeline without any changes. Okay. And then I can fit my data, fit my models, these min-max scalar, standard scalar. अभी एक interesting concept discuss करते हैं. Suppose in your training data, the minimum age was 30. Let's say minimum age was 30 and maximum was 85. Right? Based on 30 and 85, you are going to get a scale of 0 to 1. Now, let's say in your test data, minimum value became 28 and maximum value became 87. What will you do now? What should we do now? So in that case, my value will be less than 0 and my value will be greater than 1. Riddhi, we can revise the min-max value. That's totally true. But for this new test data, I don't have the output. I'm assuming that I cannot use the output. So I cannot train on this test data, right? I have to make a prediction on this data. When making a prediction, I have to transform the data into the scale that the model has seen. Then when I transform, the value will obviously be less than 0 and greater than 1. Why? Because my transformation is age minus minimum val divided by max val minus minimum val. This max val and minimum val are training data ka values. Do you get my point?
Sir,
This is, one second, Pranav. This is training data ka maximum and minimum. When I transform for the testing data, I will have to use the same one, right? And the value that I will get will be less than 0 and greater than 1. Okay. Riddhi, are you clear? Yeah, Pranavi, please continue.
sir, but we will first pre-process the entire data,
No.
transform everything and then divide, no? Train
No,
and test. तो
no.
कौन से step में हो?
That does not make sense ना. आप सोच के देखिए. जब आपको नया डेटा आएगा, तो आप अगर प्री प्रोसेसिंग में नया डेटा का इंफॉर्मेशन इंक्लूड कर दे रहे हैं, तो वो गलत है ना. टेस्ट डेटा को हम कैसे ले रहे हैं? वी आर अज्यूमिंग दैट टेस्ट डेटा इज डेटा दैट द मॉडल विल नेवर सी.
Correct.
We are simulating a situation of us getting new data to make a prediction, है ना? In that simulation, we shouldn't be using the test data before at any point of time, which is why you see ये जितने भी functions को मैं fit कर रहा हूँ, fit करने का मतलब क्या है? ये maximum value और minimum value के basis पे transformation करना. I am only fitting on the trained data. Test data को मैं सिर्फ transform कर रहा हूँ. Are you getting my point?
Transforming based on the trained data.
यस, अभी मान लो आप अज्यूम करो कि आपने 100 पॉइंट्स पे ट्रेन किया, ठीक है, अब आपको 101 पॉइंट आता है. You don't know anything about that 101 point, right? You have to treat it based on your current knowledge, current learning of the model. So I am trying to create that simulation of 100 and 101 with 70:30. So 30 is being treated as test data so that I will apply that transformation on that 30 points.
Okay.
ट्रेन डेटा इसी तरीके से यूज होगा.
तो सर एग्जैक्टली ये ट्रेन और टेस्ट का स्प्लिटिंग कौन से स्टेज पे होता है? फर्स्ट हम पूरा डेटा को लेते हैं अंदर एंड वी क्लीन इट.
या
then we do this categorical feature selection.
यस,
categorical
तो
numerical ये
फीचर
सब हो गया.
सिलेक्शन कैन ऑकर आफ्टर दिस, नॉट बिफोर.
अच्छा,
बिकॉज
तो
आप प्रोसेस कर रहे हो ना, मिन मैक्स स्केलर, स्टैंडर्ड स्केलर, ये सब आप लगा रहे हो, तो उसके बाद
पहले क्लीन करते हैं हम डेटा को.
यस,
उसके बाद हम टेस्ट और ट्रेन को स्प्लिट कर देते हैं.
यस,
एंड आफ्टर दैट वी चूज विच इज अ सिग्निफिकेंट इंडिपेंडेंट वेरिएबल.
यस.
और उसके बाद हम ट्रांसफॉर्मेशन करते हैं.
सिग्निफिकेंट वेरिएबल भी ट्रांसफॉर्मेशन ही तो प्री प्रोसेसिंग स्टेप है ना, इसके बाद आएगा फीचर सिलेक्शन.
अच्छा,
ओके, मतलब आप
Okay.
ऐसे लॉजिकली सोचो, आपके पास न्यू डेटा आया, ठीक है, ब्रांड न्यू डेटा, आपने ऑलरेडी ट्रेन कर लिया है मॉडल, अब आपके पास नया डेटा है, तो आप पहली चीज क्या करोगे? यू विल डू द ट्रांसफॉर्मेशन, राइट? जब आपने क्लीनिंग का प्रोसेस किया ना, तो आपने डेटा की इनकंसिस्टेंसीज को हैंडल करने का ट्राई किया, उसको आप सेपरेट मानो. अब जब आपके पास नया डेटा आएगा, तो ये नया डेटा के ऊपर आपको ऐसे प्रोसेसेस लगाने जो आपके मशीन लर्निंग मॉडल ने डेटा देखा है जिस फॉर्मेट में, वो फॉर्मेट में आपको कन्वर्ट करना है.
हाँ.
ओके, सो ट्रांसफॉर्मेशन पहले होगा, राइट? फिर फीचर सिलेक्शन और एलिमिनेशन होगा. क्योंकि आपका फीचर सिलेक्शन किस बेसिस पे फीचर सिलेक्ट करेगा? डेटा के बेसिस पे. और आपका डेटा अगर आप बिना ट्रांसफॉर्म किए भेजोगे तो फीचर सिलेक्शन होगा नहीं, राइट? समटाइम्स इंटरचेंजेबल होता है, आई वुडंट डिसएग्री, बट वो केस बाय केस बेसिस पे होता है, ठीक है? लाइक अगर आपका डेटा सेट का साइज बहुत बड़ा है, तो आप ट्रेन टेस्ट स्प्लिट पहले करोगे, उसके बाद आप बाकी सारी चीजें कर सकते हो, बिकॉज योर अजम्पशन वुड बी द ट्रेनिंग डेटा विल कवर एवरीथिंग दैट द टेस्ट डेटा हैज. बट अगर आपके पास लाइक 15 पॉइंट्स है, इसको आपने पहले ट्रेन टेस्ट स्प्लिट कर दिया, लेट्स से 10 और 5 में, मैक्सिमम वाला पॉइंट अगर 5 में आ गया, तो फिर आपको 10 में जो मैक्सिमम मिला है दैट विल नॉट रिप्रेजेंट द ट्रू डिस्ट्रीब्यूशन.
और ये मिन मैक्स स्केलर कैटेगोरिकल पे कैसे लगेगा?
Oh yeah, that's wrong. This will be numerical column. Okay, that will be numerical, don't worry.
Okay.
This was just an example to show the pipeline. ठीक है?
Yeah.
Pratim, I was saying कि देखो, I have to consider the situation that I only have the trained data to learn from. I had already explained why do we need splitting. ठीक है? Now I only have the trained data to learn from. So all the processing transformations, all the handling I do on the data, I have to assume that I don't have anything other than the trained data. So I'll do everything on the trained data. I am going to assume test data is brand new data that I receive. So test data पे सिर्फ transformation लगेगा. Fitting जो होगी वो trained data पे होगी. So trained data में fitting होती है and then transformation होता है. Test data पे सिर्फ transformation होता है. Is that clear? Any questions, guys? It's good to stop here and ask any questions if you guys have any. Pratim, are you clear about the question you asked? How are you getting value? Because आपका minimum value change हो गया ना? So what was the function here? ये function था, right? अब अगर आपका मिनिमम वैल्यू चेंज हो गया है तो जब 28 को आप ट्रांसफॉर्म करोगे तो 28 माइनस 30 होगा डिवाइडेड बाय मैक्सिमम एज माइनस मिनिमम एज, मैक्सिमम माइनस मिनिमम तो ये ओरिजिनल होगा 85 माइनस 30, राइट। तो ये वैल्यू नेगेटिव आ गई ना, तो ये लेस देन 0 हो गया। सिमिलरली अगर आपका वैल्यू 87 हो गया तो 87 माइनस 30 डिवाइडेड बाय 85 माइनस 30, तो ये वैल्यू ग्रेटर देन 1 हो गई। इज दैट क्लियर प्रतिम? एनी अदर क्वेश्चंस गाइस? So guys, the project that you will do, उसमें ये सारी चीजें और clear होंगी. I am taking you guys through the concepts, but there'll be case studies and projects where you will do this from scratch. तो आपको समझ में आएगा. Right now, your focus should be understanding the code as well as understanding the logic of doing certain things. The order in which you do these, that can vary by case to case basis. ठीक है? It depends on the size of the data, the domain, the business, etc., etc. Okay, so once we've done this processing, we are going to go with the recursive feature elimination technique. अब ये recursive feature elimination technique क्या है? This is basically a very logical approach to feature selection. ठीक है? Why is it a logical approach? The idea is, if I remove or add a column to my model, if the accuracy increases significantly, I keep that column. Otherwise, I drop that column. Is that clear, everyone? Let's say I have 100 possible features that I can use in my machine learning model. I start with one feature and I observe performance. Obviously, the performance will be very low. Then I add one feature. If my performance increases significantly, that means the newly added feature was valuable. So, if the performance increases, I keep the column. Otherwise, I remove the column. Then I try with the next feature. So after trying out all the features, I will get to know and I will keep only those columns that are significantly adding to my performance, to my accuracy measure. Is that clear, everyone? Any questions here? Right? इसका reverse क्या हो सकता है? Suppose I have 100 possible features. Right? I start building a model with all of them. Then I remove one feature. If I see a significant drop in my performance, then I won't remove it. I'll add it back basically. Right? But if I see an insignificant drop, if I see an insignificant drop in my performance, then I'll just go ahead and not have it in my data. Clear है सबको? Guys online, everyone, yes or no? Yes, that is possible, Pratim, sometimes. Because ये जो p value और chi-square test होता है ना, ये generally linear होते हैं. But there are some variables जो non-linear affect करते हैं. I'll give you an explanation with a diagram once. Suppose a variable there is a variable that has effect like this. Something like this. है ना? So this will be missed by p-value and chi-square test. Because for a lot of points, it has no effect. है ना? But after this threshold, it starts having a huge impact. तो नॉन लीनियर इम्पैक्ट जो होता है ना, वो पी वैल्यू से बहुत बार मिस हो जाता है. पी वैल्यू, काई स्क्वायर टेस्ट, एटसेट्रा एटसेट्रा. So you can cross validate with performance of the model also. Is that clear? Pratim? Yeah? Okay. We import the library, recursive feature elimination with cross validation. We import the model that we are going to use, right? We are going to initialize the model that we are going to use. Then scoring is equal to negative mean squared error. This is how we are going to check the performance of the model, right? We are going to check the performance of the model. This is the performance measure. This is the model that we are going to use. Step is equal to 1. That means at one point of time, I am going to only remove or add one feature. If I increase the step size, then at once it is going to remove 5 columns or add 5 columns, right? Then I fit it on my training data, right? After fitting it on my training data, I will get to know. I have not split the data yet. Yeah. I will have to do categorical transformation also. I will run the entire notebook once. Okay. This will take some time. Also, I think a lot of you are confused about the step-by-step process. तो ऐसा होता है कि like suppose when you get the data, right? Like you can actually say, like one of the students was asking a question, कि Pranjal, I removed the outliers from the data beforehand. Why did I not remove the outliers from the training data, fitting on the training data, and transform on the test data? Do you guys know the answer to that? Any logical explanation? Anyone? जो outlier removal है वो पूरे डेटा पे क्यों हो रहा है?
Because then the model will be trained wrongly if I do not remove the outliers first.
That is correct. If you do not remove outliers, right, then you are going to be training on the wrong data. And correspondingly, you are going to be testing on the wrong data as well, right? So outlier removal is a process considering that the data has problems. Okay. You need to solve that problem before proceeding further. 1 second, ये error कौन सी line में आ रहा है? Yeah, just to complete the point, outlier removal happens before because you cannot train the model on wrong data set. Plus, you're also going to do visualization, other analysis. You don't want outliers to impact that. But machine learning specific use case में आपको अच्छे डेटा के ऊपर ही ट्रेन करना है, तो आउटलायर रिमूवल प्रोसेस पहले हो जाता है. नाउ टू ट्रेन अ गुड मॉडल ऑन द राइट फॉर्मेट ऑफ डेटा यू नीड प्रोसेसिंग. दैट प्रोसेसिंग के पहले ट्रेन और टेस्ट स्प्लिट हो जाता है. आई होप आई एम क्लियर टू एवरीवन. यस और नो? Okay. So recursive feature elimination obviously takes some time, but after it runs, it is going to tell you the features that are important with the true and the features that are not important with a false. And when it gives you a false, it gives you a ranking of falsehood also. So suppose you want to have all the features with the rank 1, which are obviously the most important, but you're also okay with having all the features which have rank 2. Up till rank 2, you are okay to accept. Post that you want to drop. Okay. So if you see Xtrain, let's try. Right. Here you can see that there are these many columns, right? Out of them, which ones are useful that you are going to get using the true and false. So you can actually filter out the columns that are not true, right? So you had Xtrain. This was the original data. Xtrain was actually coming from X, right? So X dot columns, and then you can pass this entire index, right? Basically RFE, recursive feature elimination dot support. So this is going to give you the columns that are actually useful. Are we clear, everyone? Time spent is useful, age is useful, average income, internet usage. Add topic is not useful. Country name is not useful if someone clicks or does not click. Right? City name is also not relevant. Sex is relevant, time period is relevant, weekday is relevant, month is relevant. Okay, that is what the performance-based feature selection got you.
Sir?
Yeah.
Sir, in the last class, we have already done the feature selection, right? Using the category one, chi-square and all that. So this is like one shot.
This is one shot, but the strategy is different ना. अभी हमने मॉडल को इन्वॉल्व कर दिया. पहले हम सिर्फ स्टैटिस्टिकली डील कर रहे थे. पहले जो हम कोरिलेशन, काई स्क्वायर कर रहे थे, व्हाट आर दीज? दीज आर स्टैटिस्टिकल मेजर्स, राइट? नाउ वी आर इन्वॉल्विंग द मॉडल. आप एक चीज सोचिए, स्टैटिस्टिकल सिग्निफिकेंस कैसे आता है? वेरिएंस से, राइट? द मोर समथिंग वेरीज, it has a higher statistical significance. Obviously varies with respect to the model, with respect to the target value. But model में actually में वो feature useful है कि नहीं for making the prediction, that was not known. So ये भी feature selection का ही part है, but इसका strategy थोड़ा different है. We are using the original model that is going to help us in make the prediction, and we are asking that model that do you improve upon adding this feature or not. Okay.
Yes. Okay.
थोड़ा सा मतलब स्टैटिस्टिकल एंड मशीन लर्निंग को आपको अलग करना पड़ेगा.
Okay.
ये मशीन लर्निंग स्पेसिफिक फीचर सिलेक्शन है, और पहले आपका फीचर सिलेक्शन था कि इफ आई जस्ट आस्क यू, कैन यू टेल मी प्रणवी व्हिच वंस आर statistically significant? That was the question. Now I'm asking the question, which features are useful for the model? There can be statistically significant features which are not useful for the model. Okay, and that is why this step is essential. Clear hai?
Yes.
Okay, ranking can be seen with the RFE.ranking. सेकेंड रैंक वाला तक कंसिडर आपको करना है, थर्ड रैंक तक कंसिडर करना है. सो राइट नाउ वी हैव लाइक लेस नंबर ऑफ फीचर्स, सो यू सी रैंक 1 2 3 4. बट इफ यू हैव लाइक 200 फीचर्स, 300 फीचर्स, देन यू विल गेट लाइक 1 के बहुत सारे होंगे, 2 के बहुत सारे होंगे, 3 के बहुत सारे होंगे, 4 के बहुत सारे होंगे. तो यू कैन सिलेक्ट अप टू द मैक्सिमम रैंक यू कैन एक्सेप्ट. ओके, क्लियर है? Any questions, guys? I'll give you guys a minute. Let me know if there is any conceptual clarity that you guys need.
सर, तो अगर बहुत सारे कॉलम्स हैं, there are too many ones, so then how do I tag them?
How do you tag them?
मतलब अभी सपोज 10 ones है, then मतलब ये इंडेक्स में से ढूंढना मुश्किल हो जाएगा ना, कौन से.
आपको इंडेक्स से ढूंढना क्यों है? ये तो कोड से आएगा ना.
हाँ, बट 2 तक आपने बोला, 3 तक ले लो. So which column matches the third ranking?
ओके, तो हम क्या करेंगे?
That way I'm asking.
सो ये ट्रू फॉल्स वाला क्लियर है, ठीक है? ये रैंकिंग का प्रॉब्लम है, राइट? मैं क्या करूंगा, मैं रैंकिंग से ट्रू फॉल्स निकाल लूंगा, ठीक है? ट्रू फॉर आई इन RFE ranking if I less than equal to 3, let's say less than equal to 2, ठीक है? Else false. What did I do wrong? Okay. True for I in RFE ranking.
Should we specify the range?
नहीं, रेंज स्पेसिफाई नहीं करना है. Python comprehensions with if else. I think मैं सिंटैक्स में कुछ गड़बड़ कर रहा हूँ. Yeah, sorry, my bad. ठीक है, आपने कन्वर्ट कर दिया. आप देखो, जिसका रैंक 2 था, विच वाज द 5th वन, वो भी ट्रू हो गया. 3 और 4 फॉल्स है. देन अगेन बाकी सारे ट्रू. डज दैट मेक सेंस?
या बट आई वांट टू नो, ये जो सेकंड रैंक है वो कौन से कॉलम को डिनोट करता है?
तो वो तो ये अभी किया ना हमने, वापस ये कर लीजिए. इसमें x डॉट कॉलम निकाल दीजिए ट्रू फॉल्स में,
ठीक है.
और स्क्वायर ब्रैकेट लगेगा ना यहाँ, राइट? अब आपका ऐड टॉपिक आ गया. रिमेंबर, पहले ऐड टॉपिक नहीं था.
Yeah, so if there are like 20 columns, so I'm asking कि ये second, I hope you understand. So second column, how will I?
Equal to 2.
Yeah, this is what I'm asking. Okay.
जस्ट अगर आपको 2 वाले ही चाहिए तो.
हाँ.
अभी क्लियर है?
हाँ, ठीक है.
Sir, how do we decide in RFECV that we want to keep features having a rank of 2 because the function is already eliminating the insignificant? No, so it's not eliminating. देखो, यहाँ पे eliminate हो रहा है support वाला, वो आपको सिर्फ true false दे रहा है. तो whatever is true it is accepting, whatever is false it is rejecting. ठीक है? फिर आपको जब रैंकिंग मिलती है ना, तो आपको पता चलता है. अब देखो क्या होता है, सिग्निफिकेंस जो है ऑफ मॉडल परफॉर्मेंस, right? That significance for you might be 0.2%. For someone 5% might be insignificant. Right? मैं आपको एक एग्जांपल देता हूं. अगर आपको गूगल का कोई ML मॉडल मिलता है और उसमें आप 0.1% भी परफॉर्मेंस बढ़ा सकते हैं, तो दिस इज अ बिग बिग अचीवमेंट, राइट? बट अगर आपको कोई बहुत सिंपल बेसिक मॉडल मिलता है, उसमें आप 2% एक्यूरेसी बढ़ा भी देते हैं, तो इट माइट नॉट हैव एनी वैल्यू। तो जो सिग्निफिकेंस वैल्यू है ना, दिस डिपेंड्स ऑन अ लॉट ऑफ फैक्टर्स। तो अब आपको रैंक 2 लेना है। मान लीजिए कि रैंक 1 में आपके पास सिर्फ 4 ही कॉलम आए एंड वो 4 कॉलम से आपको परफॉर्मेंस मिल रहा है 70-75%। अब आपने रैंक 2 को इंक्लूड कर दिया, बाकी सारे, सो यू सी इंडिविजुअली रैंक 2 वाला जो एक कॉलम है, दैट्स नॉट एडिंग वैल्यू, बट कॉम्बिनेशन ऑफ मल्टीपल रैंक 2 कॉलम्स विल एड वैल्यू। आर यू गेटिंग माय पॉइंट, प्रतिम? तो सिलेक्टिंग 2 multiple columns with the rank 2, that will add a significant value. तो आप rank 2 तक लेते हो, 3 तक लेते हो, that depends on how much feature elimination are you okay with not having. प्राइमरी फीचर सिलेक्शन तो यही हो गया। अब आप चाह रहे हो कि फीचर सिलेक्शन से जो मॉडल ने मेरे को बताया उसमें मैं थोड़ा एडजस्ट करना चाहता हूं, दैट इज व्हेन यू कैन टेक द रैंक 2 आल्सो। कूल है? एनी फॉलो अप क्वेश्चन, प्रतिम, प्रणवी? क्लियर? ओके, ठीक है। So this is the code I had actually written for one of the students. They wanted to know, Pranjal, what if we implement it separately, not using the library? So do not worry about I mean, in the advanced ML course, you will learn about what is gradient descent, what is loss minimization, what is the different kinds of maximum likelihood estimation. This is just a code for all of you to look at, read and try and understand. ठीक है? आप मैथ्स भी अगर इसका पढ़ेंगे तो you'll be able to relate it with the code. ठीक है? I'm not discussing it because for us scikit-learn model logistic regression is just 3 lines, 4 lines of code. But if you did not have logistic regression with scikit-learn, you could have implemented the whole thing from scratch and that is added in your notebook. ठीक है? So this is just doing it without the scikit-learn module and this is all written in scratch. Otherwise, for you to implement logistic regression without knowing the mathematics behind logistic regression, you can directly import it from the scikit-learn module and implement it like this, right? Again, logic being, you are going to first initialize the logistic regression model, then you are going to fit it on the trained data, and then you can test it on the test data, predict it on the test data. Clear, everyone? ये हमने पिछली क्लास में भी डिस्कस किया था. If you want to record the training time, etc., you can. Otherwise, usually you don't need to record the training time. Okay. अब एक चीज समझते हैं. You got the actual test values. This is what you already know, but you've not used it anywhere. Then you've got the predicted values. Now you want to analyze the performance. Okay, you want to analyze the performance. Does everyone remember in regression, we will always talk about the error. And so we will try to reduce the error or basically difference between actual and predicted. Does everyone remember this? Any confusion here? Guys online, everyone? You guys remember this? Right? For classification, we are going to look at accuracy. Because we are either right or we are wrong. So we want to increase the accuracy. So now I'm going to talk to you guys about multiple metrics that help us to find and compare the performances, right? So there is confusion matrix, there is classification report, there is ROC, AUC curve, accuracy score, F1 score, etc., etc. Okay. So first thing, classification model mein, does everyone remember us discussing true positive, false negative, true negative? Right? That is what the confusion matrix gives us. Right? If you want to use confusion matrix, you can pass the Y test and you can pass the y pred, whatever you are getting from the prediction. Result 3. And you get the so Pratim, I'll cover that later towards the end of the class. Okay, don't worry. Normalization and standardization are both the same. For all practical purposes, normalization and standardization are the same. Right? If you just search normalization, it is often known as scaling normalization. Standardization is basically Z-score standardization. तो जो हम लोग अभी तक scaling की बात कर रहे थे, that's basically normalization, min-max scaling. Standardization, remember I said subtract by mean and divide by standard deviation. Right? So that is largely the difference. The transformation functions are like that. You see this, any curve can be converted to a curve with an average value of 0 and standard deviation of 1. That is the process of standardization. And normalization means to rescale the values in the range of 0 to 1. So जो हमने अभी पढ़ा है वो normalization है. Standardization is the formula that I was explaining to you guys here somewhere. Where did it go? This one, right? So you subtract with the mean value and divide by the standard deviation. What this will do is it will give you a normal distribution. Normal distribution का मतलब mean is equal to 0 and standard deviation is equal to 1. Okay, this also brings down the scale, but it is not necessary that it will have the range 0 to 1, but it will have a normal distribution, this kind of bell curve. Okay, and like I said, most models assume that your distribution is standard, normal distribution, and that is why this kind of scaling helps. Okay, if there are any follow-up questions, I'll take it towards the end of the session. Okay, great. So guys, confusion matrix, this gives us true positive, true negative, false positive, false negative, right? That is the confusion matrix. अब आते हैं थोड़ा और detail पे. There are two very specific measures called precision and recall. Okay, precision and recall. So first, let us look at use cases of precision and recall. Okay. When initially COVID happened, right? What did we want from COVID tests? True positive, obviously. True negative, obviously. But when you talk about false positives and false negatives, did we have a bias of any one of that? My internet is a little choppy today, so I'll turn off the video. Yeah.
False positive.
False positives. So we wanted false positives.
As opposed to false negatives, yes.
We wanted false positives as opposed to false negative. I think that statement is incorrect. I'll tell you why. Originally, जब COVID हुआ था, तो there was shortage of a lot of beds in hospitals. False positive means I predicted positive COVID, but the person did not have COVID. है ना? So in the scarcity of resources, I will not want false positives, or I would want false positives to be less. Okay. I mean, there is a classical movie. I think you guys have watched the Talwar movie. It's from Irfan Khan. Did anyone watch that movie? Did anyone? Yeah, this one. Right?
I mean,
So
we
there's a
know
very-
the premise. Yeah.
Yeah. So there's a very famous dialogue in this movie, which I mean, it relates of how I think about crime and etc. Right? So it's very important for the innocent to be saved, even if a few criminals have to be left. Right? I mean, the dialogue was in Hindi, but I'll give you the gist. The idea was that you must ensure legally that you protect the innocent. No innocent should be charged as guilty. And I am ready to compromise to free some really guilty people for that. Right? So I must make sure that no innocent one gets charged as guilty. तो idea वही है कि जब hospital beds कम है तो I want to make sure that जिसको COVID नहीं है उसको मैं bed ना दे दूं. Because anyway there are a lot of people who are having COVID that are not reporting COVID. So false negative is fine. कोई आया चेक कराने, मैंने बोला कि आपको कोविड नहीं है, ठीक है, तो they'll go back home. But मेरे को पास हॉस्पिटल बेड्स का शॉर्टेज है. It's fine if there are certain people who have COVID and are not treated, rather than people who do not have COVID and are occupying hospital beds. Does that make sense?
So this is subjective in that case, no? I mean,
A little.
yeah.
I agree. It is a little subjective. Okay, but like when you consider time zone, like एक time था, like अभी अगर किसी को कोविड होता है, अभी अगर किसी को कोविड होता है, तो I am fine with having as many false positives as you want because hospital beds available है, right? गलत भी predict हो रहा है कोविड का, तो भी hospital beds available है, so patients can come, they'll get further checking done. Like उस time पे prediction कैसे हो रहा था? They were using that like earbud kind of a thing, right? Swabs. तो उसका prediction उतना accurate नहीं है. But when you do a blood test, when you do like microscopic tests, then you get to know for sure कि उसमें COVID है कि नहीं. So this situation demands a particular kind of bias towards false positive or false negative. Right? Take for example, let's say some government scheme. Right? There are government schemes. If the resources are available, then we are fine with having false positive. Like someone is not let's say coming from a particular underprivileged class, but they are claiming underprivileged resources. If there are ample resources, we are fine with false positives. People who are lying, we can take them. We want to ensure that people who are underprivileged, we cover them. Right? For that, if we have to handle some false positives, we will. But if the resources are scarce, then we cannot tolerate false positives. Right? Even if a few really underprivileged people do not get the service, we are fine. But we don't want to give that service to someone who is not worthy of it. Does that make sense? All of you? I mean, yes, the conversation is a little subjective, but just consider that what I am saying, if that is the ideology of the government, then you would prioritize any one of these at different timelines, right? The concept to be understood is that you might be prioritizing one over the other.
Yeah.
Right? So you have to understand that there is a trade-off. Trade-off matlab, if you want to reduce false positives, that means you want to make sure, you want to be hard on yourself on the model that I do not want wrong positive predictions. Okay. If you look at a confusion matrix, I'll just go to this confusion matrix. Let's say this is actual 0, predicted 0. If 0 is treated as positive, this is true positive. This is true negative. This is false positive. Actual predicted value was 0, but actual is 1. So this is false positive. This is false negative. The sum of this box has to be constant, yes or no?
Yeah.
Because that is the total number of predictions. Because the sum of this box has to be constant, if I reduce false positives, the value has to increase somewhere.
Yes.
Right?
Hmm.
So more often than not, that value will split itself in these three. Now, we don't have a problem in these two increasing, but we do have a problem with this increasing. So there is always a trade-off when you try to reduce false positive, your false negative will increase. And vice versa, when you try to reduce false negative, your false positive will increase. Clear hai sabko? Yes, no?
So the margin of error is still the same, right?
Yeah, total error will be the same.
Yeah.
Accuracy will be the same. देखिए अब हम लोग accuracy से एक level और deep जा रहे हैं. हम लोग एक level और deep जा रहे हैं. Like take for example cancer, right? You'd not want to tell someone who does have cancer that they don't have cancer. So false negative is not acceptable. But someone actually does not have cancer, you predict that they have cancer, which is a false positive. They do further tests, right? They do further tests and you get to confirm that you don't have cancer. देखिए machine learning is for initial prediction. Ultimate medical test तो होगा ही, right? So cancer prediction में I'm not okay with false negatives. I am okay with false positive. Does that make sense? I cannot tell someone that you do not have cancer who actually has cancer. Right? Because then they are not going to go for further tests, right? Am I making sense, everyone? Yes or no?
Yeah.
Right? But अगर आपने गलत positive prediction किया है, तो ultimately there will be more tests and eventually you will know that you don't have cancer and you will not going to proceed further. है ना? But if you miss someone who does have cancer by telling them कि you don't have cancer, then it's a problem because they are not going to get further tests and it's going to worsen in some time. Right? So there is a trade-off. You have to decide in which particular case, what do you want to prioritize? And based on that prioritization, you are going to choose one of the two metrics, either precision or recall. Precision measures the accuracy of positive prediction. That means out of the ones that I predicted positive, that is true positive and false positive, out of the ones that I predicted as positive, how many are really positive? This tells me the strength of my positive prediction. On the other hand, recall tells me out of the actual positives, true positive मतलब positive था, false negative मतलब वो actual में positive था. Out of the actual positive, how many could I find out? ठीक है, तो इसको एक लॉजिकल अंडरस्टैंडिंग से समझते हैं. कोविड के टाइम पे if I was looking at precision, I was basically focusing on my resource optimization. कि जितने लोगों को मैं बोल रहा हूं कि आप पॉजिटिव कोविड पॉजिटिव हो, उनमें से कितने एक्चुअल कोविड पॉजिटिव है, ताकि मेरे रिसोर्सेज सही से यूज हो. ऑन द अदर हैंड, अगर एक नई डिजीज मिलती है मुझे, उस सिचुएशन में आई वुड लाइक टू फाइंड आउट ऑल पीपल हु माइट हैव कोविड. उसमें से बहुत लोगों को एक्चुअल में होगा, बहुत लोगों को नहीं होगा, दैट्स फाइन, बट आई वांट टू कवर ऑल द केसेस टू सिक्योर द रेस्ट ऑफ द पॉपुलेशन. इज दैट क्लियर गाइस ऑनलाइन? जब कोविड स्टार्ट हुआ था, so why was the government banning a lot of things? Why were they imposing restrictions? Because they wanted to stop the flow of COVID, है ना? So they did not care if they found out some people who did not have COVID and admitted them, because they were trying to save the larger population. After COVID actually, burst out, when the hospital beds were not enough, resources were scarce, oxygen cylinders, etc., etc., then the government wanted to be very selective. Hospitals wanted to be very selective. Like a lot of people who were very healthy, they had COVID symptoms. The hospital said that your health and immune system is very nice. You don't need to come to the hospital. Stay at home and rest. Right? That also happened. Why? Because they wanted to make sure that the resources they have are reserved for the most critical patients who have a higher chance of dying. Is that clear, guys? Precision कब काम आएगा, recall कब काम आएगा?
सर,
हाँ बताइए.
सर if I simplify, अगर आउटपुट मेरा 0101 है, तो और मैंने जो प्रिडिक्ट किया, तो कितने एक्चुअल में वंस है और मैंने कितने वन प्रिडिक्ट किए, वो प्रिसीजन बताएगा.
Yes.
और मैंने कितने जीरोस प्रेडिक्ट किए वो रिकॉल बताएगा?
नहीं,
हाँ,
देखो
रिकॉल एक
मतलब
बार
ऐसे
सर।
समझो, सपोज योर मॉम गिव्स यू अ लिस्ट ऑफ ग्रोसरीज टू बाय, ठीक है, सम वेजिटेबल्स।
हाँ,
आपकी मम्मी ने आपको जितना बोला, लाइक लेट्स से शी टोल्ड यू वर्बली कि ये सब्जी लेके आना है, राइट? अब आप सब्जी के दुकान पे गए, राइट? व्हाट आर यू डूइंग देयर? यू आर ट्राइंग टू रिकॉल व्हाट योर मॉम सेड, है ना? आउट ऑफ
यस,
ऑल द vegetables that your mom had asked you to get, you are recalling the ones that you can recall and ask for that vegetable. Then you come back home. Then you get to know that out of all the vegetables your mom really wanted you to get, how many did you bring? That is precision of your vegetable purchase. Does that clarify a little bit more?
yeah. So recall is how many I was not able to
Not
predict.
able to के साइड से मत सोचिए, जितनी
अच्छा,
सब्जियां लानी थी उनमें कितने आप ला पाए आउट ऑफ ऑल द पॉजिटिव्स दैट, देखो फॉल्स नेगेटिव क्या है? फॉल्स नेगेटिव मतलब एक्चुअल में पॉजिटिव था, राइट?
हाँ,
तो आउट ऑफ ऑल द एक्चुअल पॉजिटिव्स हाउ मेनी कुड यू कैच?
ओके,
ओके,
हम्म,
एंड ट्रू पॉजिटिव प्लस फॉल्स पॉजिटिव मतलब आउट ऑफ ऑल द वंस दैट यू प्रेडिक्टेड एज पॉजिटिव, हाउ मेनी वर रियली पॉजिटिव?
ओके,
So the values in the denominator are coming from the model, and the values in the numerator, the two positives, are actually from the data.
सो दिस सेपरेट ना, ये सब मॉडल से ही आ रहे हैं। ट्रू पॉजिटिव आपको तभी तो पता चलेगा ना जब मॉडल कुछ प्रेडिक्ट कर रहा है और आपने कुछ, मतलब ट्रू आपको कैसे पता चल रहा है, ट्रू और फॉल्स? पॉजिटिव तो मॉडल बता रहा है, पॉजिटिव नेगेटिव, बट ट्रू और फॉल्स तो आपको पता चल रहा है व्हेन यू आर कंपेयरिंग द एक्चुअल विद द प्रेडिक्टेड, राइट?
Okay.
देखो सपोज आप ये कंफ्यूजन मैट्रिक्स ले रहे हो, आप 0 को पॉजिटिव मान रहे हो, तो ये पूरा पॉजिटिव है, ये वाला रो,
Yeah.
राइट? आउट ऑफ ऑल पॉसिबल पॉजिटिव्स हाउ मेनी पॉजिटिव्स कुड आई फिगर आउट?
2481.
डिवाइडेड बाय 2481 प्लस 11,
Okay. So
राइट?
the
अब आ
uppermost
जाते हैं
rectangle
प्रेडिक्टेड
is
पॉजिटिव्स पे।
precision.
प्रेडिक्टेड पॉजिटिव्स, राइट? आउट ऑफ ऑल द वंस दैट आई नो, तो पुराना वाला रिकॉल था, एक्चुअल जो एक्चुअल पॉजिटिव्स थे उसमें से आप कितने याद कर पाए, कितने आप सही प्रेडिक्ट कर पाए? और अभी प्रेडिक्शन में 0 जब पॉजिटिव है, दैट मींस आपने इन सबको पॉजिटिव बोला, उनमें से एक्चुअल में पॉजिटिव थे कितने? ये वाला बॉक्स है एक्चुअल पॉजिटिव्स का, ये वाला बॉक्स है प्रेडिक्टेड पॉजिटिव्स का, है ना? एक में फॉल्स पॉजिटिव कंसीडर हो रहा है, एक में फॉल्स नेगेटिव कंसीडर हो रहा है। बताइए, एनी अदर क्वेश्चंस? Like I always understand this with the grocery example. When I am at the store, I am trying to find out, recall all the vegetables that my mom told. Sometimes I bring some extra vegetables, right? I thought that this vegetable my mom told, but actually she did not tell that. So I'm trying to recall the vegetable she had asked me to bring. When I come back home and then I really look at the list that my mom was supposed to give me, I forgot to take that list, let's say. So then I try to compare what did I really bring out of the ones that she really wanted.
Sir, can you please show the confusion model once more?
Okay. Pratim, recall and precision don't have weightages in determine the accuracy. Accuracy के लिए ना false positive and false negative are equally treated. They are both wrong. They are both false. ठीक है? तो recall does not have an special weightage. Accuracy is true prediction divided by all predictions made. Precision and recall में हम positive और negative prediction में distinguish करते हैं. Okay. Any questions, guys? Precision recall में.
So can you please tell what's the significance of recall? The precision, we understand. What's the significance of recall?
Recall is where you want to reduce false negatives. आप देखिए इक्वेशन में अगर आपको प्रिसीजन हाई चाहिए, दैट मींस व्हाट, आपको फॉल्स पॉजिटिव्स कम चाहिए, राइट? डिनोमिनेटर ज्यादा होगा और डिनोमिनेटर कम होगा तो आपका वैल्यू बढ़ेगा, राइट? ट्रू
Yeah.
पॉजिटिव्स कांस्टेंट है,
Hmm.
फॉल्स पॉजिटिव अगर कम होगा तो आपका प्रिसीजन का वैल्यू इंक्रीज करेगा बिकॉज फॉल्स पॉजिटिव इज इन डिनोमिनेटर.
Hmm.
सिमिलरली रिकॉल में जब आपको फॉल्स नेगेटिव कम करना हो तो आप रिकॉल को बढ़ाना चाहेंगे. दिस इज अ मेजर. अगर एक मॉडल का रिकॉल कोई एक वैल्यू है लेट्स से x और दूसरे मॉडल का रिकॉल है लेट्स से y, तो यू वुड वांट टू नो कि कौन से मॉडल का रिकॉल ज्यादा है. इफ यू वांट टू रिड्यूस फॉल्स नेगेटिव्स तो यू आर गोइंग टू चूज द मॉडल दैट हैज लेस फॉल्स नेगेटिव्स. बिकॉज आप देखो अगर मैं ये 392 और 11 को रीडिस्ट्रीब्यूट करता हूं, my accuracy remains the same, yes or no?
Yeah.
Right? Wrong तो wrong है, चाहे positive side में wrong है चाहे negative side में wrong है. If I redistribute these two values, my accuracy will remain the same, but my precision and recall will change.
Yes.
Clear है? So when I want to optimize or reduce false positives, I am going to look for models that have a higher precision. And when I want to reduce false negatives, right, then I'm going to look for models that have higher recall so that I can compare the performances of two models. दो मॉडल है, दोनों का एक्यूरेसी 80% है, एक का रिकॉल x है, दूसरे का रिकॉल y है, राइट? सो यू आर गोइंग टू चूज द मॉडल दैट हैज अ हायर रिकॉल फॉर द सेम एक्यूरेसी. एंड अगर आपको प्रिसीजन करना है देन यू विल चूज द हायर प्रिसीजन मॉडल. बोलिए, एनी अदर क्वेश्चंस? Don't hesitate, guys. If it's not clear, if you're not understanding, let me know again and again. I'll try to explain in as many ways as I can. Okay? But concept clear करिए. This is very important.
सर
Yeah.
सर वही उसी मॉडल के कंफ्यूजन मैट्रिक्स में अगर मैं वो ट्रू फॉल्स पॉजिटिव और फॉल्स को इंटरचेंज कर दूं तो प्रिसीजन और रिकॉल बदल जाएगा ना?
Yeah, exactly. Precision will become recall, recall will become precision. Because देखो दोनों में true positive तो constant है ना.
हाँ.
False
तो
negative को आप false positive करोगे तो precision पुराना recall बन जाएगा, recall पुराना precision बन जाएगा.
and depending on the type of problem I have to decide which one to take up. Should it be precision or should it be recall?
Exactly.
Acha, fine.
Don't say fine. That's disappointing for me.
No. Clear, I meant.
Yeah, it should be clear to everyone. Guys, quick yes and no. नहीं clear है तो बोलिए. Do not hesitate. Is it clear to each and every one of you, precision and recall? Any question, no matter how insignificant you think it is, ask. Okay. अब देखिए क्या होगा. If you are looking for high precision models, like I said, there is a trade-off. अगर आपका मॉडल हाई प्रिसीजन होगा ना तो वो जनरली लो रिकॉल होगा, एंड अगर आपका मॉडल हाई रिकॉल होगा तो वो जनरली लो प्रिसीजन होगा, बिकॉज देयर इज अ ट्रेड ऑफ लाइक आई एक्सप्लेन्ड बिफोर. सो देयर इज अनदर मेट्रिक कॉल्ड द F1 score, which is the harmonic mean of precision and recall. It gives a higher value when both precision and recall are high, and it gives a low value when any one of these two is low. So when you want to balance precision and recall, that is when you go for F1 score. Something like this. अगर आपका प्रिसीजन लो है तो आपका रिकॉल हाई है, अगर आपका रिकॉल लो है तो आपका प्रिसीजन हाई है, right? Then there comes a point where both of them are decently high. This is the point of maximum F1 score. Any one of them are low, the F1 score will be low. The F1 score is low here, the F1 score is low here. At this point, F1 score is maximum. Okay, So when you want to balance out precision and recall, that is where you use the F1 score. Formula diya hua hai, it's a combination of precision and recall. Clear, everyone? Guys online? Yes, no? Any question? Okay, why train result? See, this should work. Why is this not working? I had created this here. Why test result 3? Right. So this is the confusion matrix that we originally had. Where is that F error coming from? Okay. The numbers might not match because of train test split and other details, right? But I hope everyone understood the confusion matrix and precision, recall, and F1 score. Guys online? Yes, no? Okay. Precision recall trade-off का एक code था that you can find online. It is just going to plot precision versus recall, right? And it's going to show you that, you know, when precision was increasing, was very low, recall was very high. Let's see if this works, right? This is the point of maximum F1 score where both precision and recall are high. Okay, and that signifies the trade-off that we were talking about. Now coming to one interesting, I would say, metric that has been very useful and has also been asked in a lot of interviews to me personally, as well as to a lot of the students I have worked with. There is a measure called ROC curve, receiver operating characteristics. Right? This comes from the topic of signal processing, how signals are transmitted in space, right? तो ये वाला जो curve है ना, this actually signifies how does false positive rate increase with respect to the true positive rate. थोड़ा सा इसमें we'll need some more focus. Okay, so let's come here. अब देखिए, it is a plot between true positive rate and false positive rate. What is the ideal curve that I'm looking for? My ideal curve is I want true positive rate to increase without any increase in the false positive rate. So x axis में movement नहीं चाहता हूं मैं, y axis में मैं infinite movement चाहता हूं. Is that understood, everyone? Yes or no? I want my true positive rate to keep on increasing y axis में, but I don't want my false positive to increase. I want to move in this direction. I do not want to move in this direction. Okay.
So rate here means occurrence.
Rate here means basically the more number of predictions you are making, the more training you are doing. Is it increasing? Like अगर आप समझो जैसे कि मॉडल का complexity आप बढ़ाए जा रहे हो, तो obviously true positive rate बढ़ेगा. But is that complexity also causing an increase in the false positive? Then it does not make sense, right? आप सही predictions कर रहे हो and equally आप गलत predictions भी कर रहे हो.
Okay.
Right? What you really want is for your model to clearly distinguish between positive and negative. For your model to clearly distinguish between positive and negative, you want to make sure that your model's positive prediction increases without wrong positive predictions. है ना? True positive prediction should keep on increasing without the increase in false positive. आप एक बात सोचो, सपोज मैं ट्रू पॉजिटिव बोलता जा रहा हूं, वॉट एवर प्रेडिक्शन इज कमिंग आई एम क्लेमिंग इट एज ट्रू पॉजिटिव. ठीक है, वॉट एवर प्रेडिक्शंस आई एम मेकिंग आई एम कॉलिंग इट पॉजिटिव. सपोज दिस इज माई आइडिया, एवरीथिंग दैट आई प्रेडिक्ट आई ओनली प्रेडिक्ट इट एज पॉजिटिव. तो क्या होगा, ट्रू पॉजिटिव तो इंक्रीज करेगा, बट साथ साथ में फॉल्स पॉजिटिव भी इंक्रीज करेगा. यस और नो?
Yes.
ट्रू नेगेटिव और फॉल्स नेगेटिव कब आएगा? जब मैं नेगेटिव प्रेडिक्ट करूंगा. अगर मैं नेगेटिव प्रेडिक्ट ही नहीं करता हूं तो सही प्रेडिक्शन या गलत प्रेडिक्शन से तो कोई मतलब नहीं है. आर यू गाइस गेटिंग माय पॉइंट? गाइस ऑनलाइन, यस और नो? अगर मैं नेगेटिव प्रेडिक्ट ही नहीं करता हूं तो वो प्रेडिक्शन सही है या गलत है, डज नॉट मैटर. अगर मैं सबको सिर्फ पॉजिटिव ही बोलता हूं तो क्या होगा, ट्रू पॉजिटिव भी बढ़ेगा, फॉल्स पॉजिटिव भी बढ़ेगा. तो इसका ट्रूथ क्या है? यस, गो अहेड.
So false positive is predicted is true, but actually is false.
या
Okay.
देखो हमने क्या बात की थी, देयर इज दिस स्पेस, देन देयर इज दिस स्पेस. यहां पे आपका क्या आता है, पॉजिटिव या नेगेटिव. राइट, दिस इज द प्रेडिक्टेड पार्ट. You can either predict positive or you can predict negative. है ना? This is the comparison part with reality. Either it will be true or it will be false. Right? So true means whatever you have predicted here is a correct prediction. False means whatever you predicted here is the wrong prediction. तो ट्रू पॉजिटिव मींस आपने पॉजिटिव प्रेडिक्ट किया एंड आपने सही प्रेडिक्ट किया. फॉल्स पॉजिटिव मींस आपने पॉजिटिव प्रेडिक्ट किया बट आपने गलत प्रेडिक्ट किया. इज दैट क्लियर नाउ?
Correct.
राइट. तो अगर मेरा ट्रू पॉजिटिव्स इंक्रीज हो रहा है, आई एम मेकिंग मोर एंड मोर पॉजिटिव ट्रू पॉजिटिव प्रेडिक्शंस, एंड उसके साथ में मेरा फॉल्स पॉजिटिव भी इंक्रीज हो रहा है, देन आई हैव रियली नॉट लर्न टू मेक द प्रेडिक्शन. राइट. आप एक सिंपल सा आइडिया सोचिए, इफ यू आर टॉसिंग अ कॉइन एंड मैं सिर्फ हेड्स बोलता हूं हर समय. राइट, अगर मैं सिर्फ हेड्स बोलता हूं ऑल द टाइम, देन मेरा ट्रू पॉजिटिव क्या होगा, 50%. फॉल्स पॉजिटिव क्या होगा, 50% फॉर अ सिग्निफिकेंट नंबर ऑफ सैंपल्स. यस और नो?
Yes.
Right?
Yeah.
Does it mean that I know I can really predict if it will be heads or tails? No, I'm just predicting everything as heads, right? With my true positives, my false positive count is also increasing. That signifies that my model has not learned the difference between positive and negative. ठीक है? वो वाली प्रॉब्लम ना हो, to observe that something like that is not happening, we look at the ROC curve. The ROC curve is a plot between the true positive rate and the false positive rate. Okay. True positive rate shows that my number of right predictions are increasing. देखिए अभी मेरा number of right predictions बहुत sharply increase कर रहा है, but x axis में movement नहीं हो रही है. So my true positives are increasing without a lot of change in my false positives. And then there comes a point after which my true positive is increasing by a slow rate, but my false positive is increasing by a very large rate. अभी समझ में आ रहा है? Yes or no? Guys online? Is everyone able to understand this curve? Right? अब देखो, ideally what do I want? I want a curve like this. I want this to be a straight line and then something like this. But obviously I'll not get this. I will always get a curve like this. The curve that you see is a real curve. Ideal, matlab ideal se hatke, true curve, reality. That your model will obviously increase true positive rate to a certain point. After that point of time, you will start getting more false positive rates. Okay. The code for making this plot and for getting the ROC AUC score is all here. You can read the code, you will easily understand. Okay, everyone.
So we'd always want a larger curve. I mean,
Yeah, we
the
want
area.
larger area under the curve.
Correct. Okay. So smaller curve means my true positive is not increasing much, but my false positive is increasing.
आपका smaller curve कैसा दिखेगा आप सोचिए, something like this. Straight line. With the increase in true positive, आपका false positive भी equally बढ़ रहा है, तो इसका area 0 हो जाएगा ना. Obviously ये होगा तो बहुत ही गलत है. Are you getting my point? कि आपका ट्रू पॉजिटिव बढ़ ही नहीं रहा है, फॉल्स पॉजिटिव बढ़ते जा रहा है, ये कभी होता ही नहीं है. ठीक है, तो हमेशा आपका लाइन इस लाइन के ऊपर होगा. तो आपका जो एरिया कैलकुलेट होता है वो ये वाला एरिया कैलकुलेट होता है ना. तो अगर आपका सिचुएशन कुछ ऐसा है, तो आपका एरिया कम है. यहाँ पे क्या हो रहा है, आपका फॉल्स पॉजिटिव रेट ज्यादा बढ़ रहा है, ट्रू पॉजिटिव रेट कम बढ़ रहा है. एंड मैक्सिमम एरिया क्या होगा, ये वाला. क्लियर है? So we want area under the curve to be larger for a good model. Are we clear, everyone?
Yes, sir.
Any questions in this? Otherwise, we'll move to clustering.
So what questions you were telling, what type of question comes from this?
So if you are asked that my precision, like this is the particular case scenario, what performance measure will you look at? So you'll say, I'll look at accuracy because it's a classification problem. They'll say, will accuracy perfectly justify? Then you will say, I need confusion matrix. Okay. Then they'll ask for this particular case in the confusion matrix. Can you define some other variable, other measure that will help you have a better look? Then you will say, I'd look at precision because I'm okay with false negatives. I'm not okay with false positives.
Right.
Right. So वैसे करके मतलब circular questions आते हैं. आपको बोलेंगे कि आप क्या आंसर प्रेडिक्शन कर रहे हैं, तो will you look for precision or will you look for recall? Clear, everyone? Any questions, guys? This is the time. Then we'll move to clustering. Oh, I'm sorry, I missed Pratim's question. Sir, suppose we are concerned with the accuracy of predictions of 1 in any classification problem. Should we be focused on the F1 score of 1 and should not be considered even if the F1 score is 0, is low, or there should be a balance? There should always be a balance between the two, but you will only get a balance when you have a good accuracy score first. मतलब देखो, अगर आपका accuracy 40-50% आ रहा है, तब तो आपका मॉडल क्वालिफाई नहीं कर रहा है ना. मॉडल का परफॉर्मेंस आ गया 80%, then you will look further. Precision, recall, F1 score, etc. etc. अगर आपका मॉडल का परफॉर्मेंस ऐसी है तो you will not qualify that model to go further. Pratim, is that clear? If you have a question, tell me. You can turn on your microphone and ask if writing will take a lot of time. Yeah. Okay. So that was classification. Now we'll talk about clustering. ठीक है? तो पहले मैं आपको एक understanding देता हूँ. What clustering is, why do we use it, right? I hope everyone remembers the use case of clustering. Segmenting our data into groups so that those groups based on similarity can be, an action can be taken on groups. These groups are on the basis of similarity. Does that make sense? Homogeneity amongst groups. Yes. Does everyone remember that? Guys, yes or no? Guys online, does everyone remember that? Can you use polynomial regression on logistic? So, Pranavi, polynomial regression, like I said, is conversion of data to polynomial data. Ultimately, तो linear regression होता है, right?
Yes.
So, मतलब polynomial regression versus logistic regression का कोई logic नहीं है.
मतलब polynomial regression assumes that the output is in a nominal form. I mean, it's a continuous variable.
No, polynomial regression assumes that the relationships are polynomial, non-linear.
Okay. तो लॉजिस्टिक में भी तो हो सकता है ना?
नहीं, logistic is a model. Polynomial is a relationship.
So I am converting polynomial regret. I'm first converting the relationship into polynomial and then putting it into a linear regression model.
Yes.
So similarly, do I do that in a logistic? First, I
No,
convert.
logistic regression is capable of handling non-linearity.
That's what.
Okay.
So no need to do that.
Yeah.
Okay.
So, madam, you could have framed your question like, can I use polynomial transformation before logistic regression?
Oh, okay. Okay, my bad.
Can I use polynomial regression on logistic regression? So, like now when I've explained to you, you will understand why I was confused.
Yeah.
ठीक है?
ठीक है.
चलिए, guys, let's start here. Suppose this is my data. I have one x-axis. And I have one y-axis. ठीक है? Visually आपको दिख रहा है कि there are 3 clusters. Yes or no? सबको दिख रहा है? Visually there are 3 clusters. Okay. Mathematically आप कैसे figure out करेंगे? ठीक है? So the first problem of clustering is that you have to define the number of possible clusters. There is a way to automate this process to find the number of optimal clusters. But for now, assume that I have to define the number of clusters. ठीक है? तो इस case में, let's say I define that there are 3 clusters. I tell my program that there are 3 clusters. How will my program find out that 3 clusters? ये algorithm अभी हम discuss करेंगे. ठीक है? I will start the algorithm with 3 random points. 3 points randomly in my space, in my 2-dimensional space. Okay? Then, for each blue point, my actual data, I will find out the orange point closest to it. For example, this particular blue point is closest to this orange. This particular blue point is closest to this orange. This particular blue point is closest to this orange. This particular blue point is closest to this orange. This will also be to this orange. Then there'll be something which is closest to this orange, so on and so forth, right? All the blue points that are closest to a particular orange, मान लेते हैं कि ये जो 3 points है, एक का color orange है, एक का color let me give purple, right? And और एक का color let me give brown. Right? Orange, purple, and brown. I will recolor the points that are closest to my brown point to brown. I will recolor my blue points that are closest to orange to the orange color. And I will recolor the points, blue points closest to my purple to be purple. Right? After this particular setting, after this happens, what will I have? All my blue points will now be associated with one particular orange point. Is that understood? Yes or no? One particular point out of 3, orange, brown, or purple. Okay, let me just show that in a diagram that will be a little more clear. Zoom में अभी तक dynamic plotting नहीं आया है. यस, यूक्लिडियन डिस्टेंस से ही हम लोग क्लोजनेस निकाल रहे हैं। जो 2 पॉइंट्स का क्लोजनेस हम डिफाइन कर रहे हैं, राइट, दैट इज ऑन द बेसिस ऑफ यूक्लिडियन डिस्टेंस। ठीक है, एवरीवन लुक एट दिस इमेज। ओके, दिस विल समराइज द होल कॉन्सेप्ट ऑफ क्लस्टरिंग। ठीक है, in the first instance I am going to start with 3 random points. Then I will color each point in my data to the point that is closest to that point. ये वाला सबको दिख रहा है, समझ में आ रहा है? बताइए yes or no. Iteration 2. Each point in my data will be colored to the 3 random points, whichever is closest to that point. Guys online, yes or no?
Yeah.
Okay. After doing this, I am going to find out the average center of all blue points, center of all red points, center of all green points, and I am going to shift it. Can you see this blue got shifted here? This red was originally towards the left side, got shifted in the center. This green was also in the left, got shifted in the center. So that this red is now the center of all the red points. This green is center of all green points. This blue is center of all blue points. ये सबको समझ में आया? Yes or no? Guys, iteration 2.
But it's not a data point, is it? I mean, earlier blue, red, and green crosses, were they data points or they were just random data?
They were random points.
Okay.
Now they've become the center.
But
now this red represents the center of all red points. Red points are my actual data. ये black points तो मेरे original data थे ना. I started with random points.
no, I understand the dots. I'm asking about the X. You know, are they like, say, suppose my data is varying from 0.1 to 1000. That is the range. So, and step by 0.1, are these X's, you know, in the data set, or are they not really a part of data set? And
both. They can be a part of the data set. They might not be a part of the data set. I'll tell you why.
Okay.
अभी जैसे ग्रीन पॉइंट्स इधर भी हैं एंड ग्रीन पॉइंट्स इधर भी हैं, तो अगर उनका सेंटर ये होगा तो दिस पॉइंट इज नॉट पार्ट ऑफ द एक्चुअल कम्युनिटी. Okay, so that is possible that your X might not look like a real data point, but it might be completely outskirts. जैसे अभी ये random points है, तो ये random point यहाँ से भी start हो सकता था. So this random point is nowhere the data. Over the course of iterations, these points will converge to looking like a real data point. That we'll see. ठीक है? So what steps did we take? We started with random 3 points. We found out for each data point, actual data point, which is the random point closest to it. And we shifted these random points to the center of those selected points. यहाँ तक सबको clear है? Yes or no?
Yes.
Now we follow the same process again. Now we have this blue, red, and green. These are new shifted centers. Now I am going to again do the same process. I am going to find every point that is closest to blue and mark that as blue. Every point that is closest to red, mark that as red. Every point that is closest to green, mark that as green. And after I find out all the points that are closest to green, I am going to readjust the green point. I'm going to readjust the green point. When I do it multiple times over and over, in the end, I will reach a position where I no longer have to shift the centers. अभी मेरे को shift क्यों करना पड़ रहा है? Because मैंने random से start किया था and points were scattered, distributed across space. After a point of time, I will no longer need to shift because the center will be same as the previous center. That is where my algorithm converges. Let's look at a quick video for explaining, understanding that. Not this one. Another good one. Okay, guys, can you guys all see this one by one? We started with 3 random points. पहले सब blue थे, then blue का center shifted, then red का center shifted, and green का center shifted. After a point of time, the center no longer needed to shift, and that is the point where clusters were defined. Are we clear, everyone? Yes or no? Guys online? You can see the steps being mentioned also in this video. We start update cluster assignments, update cluster centers, then update cluster assignments, update cluster centers. That's what's happening. In the end, the cluster centers no longer need to be updated. That is the point where the algorithm converges and finds the clusters. Any questions here?
How do we decide that it has converged and no longer need to be readjusted?
So आपने जो previous आपका जो center था and जो आपका नया center है, उसका एक tolerance value होता है. Let's say the tolerance value is 0.001. So if my center, previous center and my new center के बीच में less than 0.001 का gap है, based on the tolerance, I will stop the algorithm. Does it make sense?
Yeah.
Previous center to new center का जो distance है, if it is less than 0.001, which is my tolerance value, I will no longer do the updation. I will stop the algorithm. Any questions? Anyone else? Clustering का basic logic सबको समझ में आया? ठीक है, अब देखिए फंडामेंटल आइडिया क्या है. यू हैव टू फाइंड क्लोजेस्ट पॉइंट, यू हैव टू फाइंड सेंटर, ऑल ऑफ दैट. अब वो कैसे फाइंड होगा? क्लोजनेस आप कैसे डिफाइन करेंगे? डिस्टेंस से. एंड वो डिस्टेंस का मेजर क्या है? यूक्लिडियन डिस्टेंस. राइट? डज एवरीवन रिमेंबर यूक्लिडियन डिस्टेंस फॉर्मूला? Simple x1 minus x2 whole square plus y1 minus y2 whole square, right? And that will be square root. So distance between any 2 points is the Euclidean distance between them. Then I can sort the distance and I can find out the closest point. Clear hai? Any questions? Guys online, any questions? Okay. तो अभी एक एग्जांपल लेते हैं क्लस्टरिंग प्रॉब्लम का. ठीक है, सपोज यू हैव ऑनलाइन रिटेल ट्रांजैक्शन का डेटा सेट, राइट? यू हैव योर कस्टमर्स, you have their invoice numbers, the stock code, the product that they purchased, description of the product, the quantity that they purchased, date, invoice date which they purchased, unit price, customer ID and country. So you basically want to find the clusters of your customers. Okay, तो अभी क्या होता है क्लस्टरिंग में? the one problem is कैटेगोरिकल डेटा के साथ क्लस्टरिंग नहीं होती. यूजुअल केसेस में categorical data needs to be converted or transformed in a certain way that clustering can happen on it. But जो normal ordinal और nominal data sets है ना, strategies है, वो काम नहीं करती because they are not 1 or 0 numerical, right? They are 1 or 0 boolean. सबको क्लियर है? यस नो? So, because they are not numerical, distance is not a valid measure for them. Guys, yes or no? Everyone? So, हम क्या करेंगे? We will convert our data into three particular values. We are going to derive three particular values. इसके अंदर data analysis का पूरा segment है. You guys can go through that later. मैं main topic of discussion पे आ रहा हूँ. Right, all the data preparation, etc., etc. We are going to consider three factors: recency of the customer, when did they make their last purchase, number of days since then, frequency, how many transactions do they make, and monitoring, the total amount that they made a transaction for. Recency, frequency, and monitoring. Right? For each customer, we sum the total amount that they have purchased with us with a simple group by and dot sum. For each customer, we find out the number of times they've shopped with us, which is the frequency measure. We concatenate both that data frames. So for each customer ID, I have amount and frequency. I might have to do some cleaning here and there. You can see everything is written. You can go through that. Then again, based on invoice date, I am going to find out the recency of the customer. And then I am going to concatenate the recency in my data frame. So finally, I will get for each customer the amount that they've purchased for, the number of transactions they've made, and the last transaction they've made. ये सबको clear है? Yes or no?
Sir, how did you decide these columns should be kept?
Business domain understanding. You have to
Acha.
understand the domain, right?
And in no way I
आप
can use
age
a
भी add
category.
कर सकते हो. इसमें आप age भी add कर सकते हो.
हाँ.
Male भी add कर सकते हो, gender भी add कर सकते हो. I'm just showing an example. Okay.
Acha. Okay.
You can add more criterias for comparing similarity. That's always there. Okay.
Yes.
ठीक है. This is like standard of the industry for customer segmentation. That is why I showed this example कि अगर आपको कोई interview में पूछता है तो you know you have this fancy strategy कि I will compare on the basis of frequency, transaction, recency, like all of that. ठीक है.
And sir, अगर attribute में अगर कोई categorical आ गया है तो आपने बोला कि नहीं हो सकता है clustering में.
तो generally आप उसको frequency में convert कर दोगे. Like अगर इस customer ने कोई एक लाइक आपका कैटेगरी यहाँ पे जो होगा एग्रीगेशन, जब आप कैटेगरी को करोगे तो आप मोड के बेसिस पे कर सकते हो, राइट?
अच्छा.
फॉर एग्जांपल ऑनलाइन ट्रांजैक्शंस, ऑफलाइन ट्रांजैक्शन, तो कितने बार ऑनलाइन किया है ये वाला कस्टमर, उसका काउंट आ जाएगा. कितनी बार ऑफलाइन किया उसका काउंट आ जाएगा. तो वो आप कर सकते हो.
अच्छा, तो इसमें वन हॉट एनकोडिंग नहीं काम आएगा बिकॉज यू सेड इट विल कन्वर्ट इनटू बुलियन.
सो वन हॉट एनकोडिंग ही ट्रिक क्वेश्चन है. लोग पूछते हैं कि आप वन हॉट एनकोड करके क्लस्टरिंग करोगे, सही है कि गलत? तो वो गलत है, बिकॉज वन हॉट एनकोडिंग में 1 and 0 आर नॉट न्यूमेरिकल सिग्निफिकेंसेस. तो उसका डिस्टेंस जब आप निकालेंगे तो वो गलत इंटरप्रिटेशन है. लॉजिक समझ में आ रहा है, राइट? 1 and 0 जो आप 1 minus 0 का स्क्वायर करोगे तो द यूनिट इज नॉट 1 एक्चुअली, राइट? 1 represents मतलब सिग्निफिकेंस, आई मीन एग्जिस्टेंस और इनएग्जिस्टेंस, है ना?
सर बट अगर यहाँ कैटेगोरिकल डेटा है, सो फॉर ईच कस्टमर आईडी तो फ्रीक्वेंसी एक ही रहेगी ना?
नहीं, क्यों?
कैसे
अरे
सर?
एक मतलब एक कस्टमर एक ही रो में नहीं आएगा. अगर आप ओरिजिनल डेटा देख रहे हो तो मैं ग्रुप बाय करके सम कर रहा हूँ ना. सेम कस्टमर कम्स मल्टीपल टाइम्स. कैन यू सी दिस?
या करेक्ट.
जैसे मान लो यही कस्टमर आईडी का एक ऑनलाइन ट्रांजैक्शन है, यही कस्टमर आईडी का एक ऑफलाइन ट्रांजैक्शन है. तो नंबर ऑफ ऑनलाइन ट्रांजैक्शंस, नंबर ऑफ ऑफलाइन ट्रांजैक्शंस. तो आपको उससे पता चलेगा कि मेरे ये वाले जो कस्टमर्स हैं, ये जो क्लस्टर है, ये ऑनलाइन परचेज करना ज्यादा प्रेफर करता है. ये वाले जो कस्टमर्स हैं ये ऑफलाइन प्रेफर ज्यादा करते हैं. आपका एक सिंगल कॉलम था ट्रांजैक्शन मोड ऑनलाइन ऑफलाइन, उसको आपने ऑनलाइन का काउंट निकाला, ऑफलाइन का काउंट निकाला, देन 2 नए कॉलम्स क्रिएट किए. तो आप वन हॉट एनकोड करके सम कर सकते हो. दैट्स आल्सो एन अप्रोच. आर यू गेटिंग माय पॉइंट? मान लो यहाँ पे आपका एक कॉलम था ट्रांजैक्शन मोड.
ओके.
सपोज यहाँ पे आपका एक कॉलम था ट्रांजैक्शन मोड, कभी ये ऑनलाइन था, कभी ये ऑफलाइन था, ठीक है। आपने इसको किया वन हॉट एनकोड, वन हॉट एनकोड करके ये आपका बन गया दो कॉलम, एक था ऑनलाइन मोड, एक था ऑफलाइन मोड, ठीक है। वन हॉट एनकोड करोगे तो आप 010101 करके आएगा। अब आप इसको सम कर दो फॉर वन पर्टिकुलर ग्रुप बाय ऑन कस्टमर आईडी एंड देन सम दीज टू कॉलम्स, तो आपको काउंट ऑफ ऑनलाइन ट्रांजैक्शंस, काउंट ऑफ ऑफलाइन ट्रांजैक्शंस पता चल जाएगा। दैट यू कैन यूज फॉर क्लस्टरिंग। ओके,
Okay, sir.
clustering for categorical data is only valid when you are going to aggregate the categorical data points that you have already transformed, ठीक है। एग्रीगेट नहीं करोगे तो गलत। अगर मान लेते हैं कि हर एक कस्टमर का सिर्फ एक ही रो है और उस रो में आपके कैटेगोरिकल कॉलम्स एडेड है, तो वो अप्रोच गलत हो जाएगा। बट इफ यू एग्रीगेट दैट, यू सम द फ्रीक्वेंसी, काउंट एटसेट्रा, देन इट्स राइट। क्लियर है सबको? यस, नो? Guys online, any questions? Ifra, I hope your doubt is clarified. If you have a doubt, let me know. Okay, so you finally have this amount, frequency और recency. अब clustering का एक fundamental problem क्या है कि because आप distance based measure करोगे तो you cannot do that with absolute terms. Absolute value of amount का distance and absolute value of frequency का distance कभी same नहीं होगा. Is that understood, everyone? Like amount of 4310 and 1797 के बीच का जो difference है and frequency of 182 and 31 का जो difference है, उसमें amount का difference ज्यादा है but frequency का difference ज्यादा significant है. Does that make sense? Yes or no? So we need our normalization, standardization, scaling, whatever you like to call it. We need to scale our data before proceeding with clustering. Okay. Also, we should be removing logical as well as statistical outliers. ठीक है, जो हम लोग already देख चुके हैं. So I'm not diving deeper into the process. I mean, a lot of processes are, interrelated and codependent. So I will do outlier removal. Outlier removal का पूरा code यहाँ पे है. You guys can check this out. Go through it at your own time. এখন হবে না. You guys can go through that your own time. The code is already there. I'll share the notebook. Once you remove the outliers, you handle the logical as well as statistical outliers. Then you need to scale the attributes, which I'm doing here. After scaling, each and every one of them is having a normal distribution. यहाँ पे मैंने standard scaler use किया है. That's why you can see negative and positive values. If I would have used min-max scaler, then you would have seen 0 to 1. Okay? If you want to see that as an example, I'll quickly show you. Right now, every value is between 0 to 1. Okay? After you've scaled your data, then you are going to implement your k-means clustering model. Does everyone have 10 more minutes? I'll just try to cover clustering today. Guys online, everyone has 10 more minutes?
Yes.
Yeah? Okay. So once your data set is ready in the appropriate format and scaling has been done, you find out the features based on which you want to do comparison of similarity. We will basically run the k-means clustering algorithm. So k-means ke andar, the first observable problem you will see is you have to define the number of clusters. And we don't know the number of clusters. They might be 1, 2, 3, 4, 5, 6, 10, right? We don't know. So there is a particular algorithm, a strategy called the elbow curve strategy. The elbow curve strategy basically simulates different k values, different number of clusters. And based on the number of clusters, it tries to find out a measure which is basically distortion. Distortion से मतलब क्या है? ये जो final आपका cluster create हुआ है, the average distance of the center to every point in the cluster. Red का जो center है, its distance with every point in the cluster, उसका average. That gives you a measure called as distortion. That gives you a measure called as distortion. What you want, distortion obviously आप clusters बढ़ाते जाएंगे तो distortion कम होता जाएगा. You want a particular number of clusters where after that point, suppose after number of clusters is equal to 3, adding more clusters is not reducing your distortion by a huge margin. When you had just one cluster, this was your maximum distortion because every point is part of the same cluster. Then you increase the number of clusters to 2. So there was a significant drop in your distortion, right? Then you further increase number to 3. There was also a significant drop in your distortion. But 3 to 4 जब आप गए तो आपका distortion did not decrease significantly. Is that making sense, everyone? Yes or no? Guys online, everyone? Elbow method is the strategy which basically tells you the appropriate number of clusters to choose. Okay? Elbow method, the elbow curve. Okay, you can see that I have used multiple clusters. I have fit k-means on multiple clusters, and then I have basically appended the inertia. Inertia is basically the distortion measure. And then I have just plotted the inertia, the distortion. Standard squared deviation. Okay, like SSD ka full form. Then you plot this elbow curve, and based on the elbow curve, you take a decision that 3 cluster is the appropriate number of clusters. Once you do that, you then try to say number of clusters is equal to 3. Then you fit your data and you get cluster for each and every one of your points. Is that clear? All of you? Yes or no? Now you know that this particular customer belongs to cluster 0. So you can find out all the 0 wala customers, and then you can, conduct a specific activity for that cluster. Same for 1, same for 2. After identifying the appropriate number of clusters, optimal number of clusters, you can fit your data, again, not the original data, the scale data, to your k-means algorithm. And then you can basically predict the labels. This k-means dot labels is going to give you cluster for each and every data point. I have created a new column which has the cluster numbers, and this new column can be seen here. Cluster 0, 2, 2, 1, 2, so on and so forth. Clear hai sabko? Yes or no? Any questions here, guys? If you don't want to visually look at the elbow curve and decide the number of clusters, there's also something called as a silhouette score. The silhouette score actually tells you about the optimal cluster size. Okay, the silhouette score actually tells you about the number of clusters. ठीक है, अगर आप silhouette score देखेंगे 0.52 to 0.64, 0.64 to 0.67, right? 0.67 to again 0.67, then it starts decreasing. So the peak of the silhouette score, आपका silhouette score कैसा दिखेगा? It will look something like this, right? And obviously not exactly like this. It will look something like, right? So the peak of the silhouette score, and this will be number of clusters on the x-axis. यहाँ पे cluster 1, cluster 2, cluster 3, cluster 4, after that cluster 5, cluster 6, which you can see here. There was an increase in the silhouette score till here, not even till here, till here. 0.679, this was the maximum. After that, it started decreasing. Right? So it would look something like this. Increase till cluster equal to 4. After that, there is a decrease in the silhouette score. So silhouette score can actually tell you the number of clusters that you should choose mathematically. Right? Same as elbow curve. Okay. And once you have the clusters, you can do all sorts of analysis. For example, by cluster ID, I want to check out the amount of the customer. So you can see cluster 2 has the high amount customers. Cluster 0 and 1, they have almost similar amount customers. When you look at frequency, cluster 2 has the high frequency customers. Okay. 0 and 1, almost same. When you look at recency, customer 1 has highest recency. Like 0 and 1 have almost similar recency. So now you can analyze your customers on the basis of clusters that have been assigned to them. Does that make sense, all of you? Guys online, yes or no? Right? Idea is very simple. I know a lot of content covered, mathematical discussion, theoretical a little bit. You can watch the videos again. And I'll try to get the video of today uploaded as soon as possible, so that if you have any questions with respect to clustering, we can cover them tomorrow. These are also a few visualizations. When you look at them, you'll understand they are just helping you to understand clustering better. Okay, that's it. If you have any questions, we can take that up. Yeah.
So why are there outliers after we have removed outliers?
Where do you see outliers? These ones.
Yeah.
And I mean, देखो, outliers यहाँ पे जो हमने हटाए, they were extreme outliers. आप यहाँ पे देखो, these were the outliers earlier. After that, this was. तो outliers तो अभी भी है. Right? Larger outliers हट गए.
Okay.
Because आप जब original outlier हटा दोगे तो distribution भी change हो जाएगा ना. Are you getting my point? ये वाले जो outliers थे वो इस distribution के हिसाब से थे. ये वाले जो outlier है वो इस distribution के हिसाब से है. तो first time when I remove outliers, that's it. उसके बाद जो आपको outlier लग रहा है, those are basically extreme cases. Okay? मतलब ये वाले जो values है ना, ये इसके हिसाब से outlier नहीं है. Is that clear? Original raw data के हिसाब से these values are not outliers. आप एक चीज सोच के देखो, पहले का जो 95 परसेंटाइल से ऊपर और 5 परसेंटाइल के नीचे था वो मैंने हटा दिया. अब जो बचा मेरे पास उसका भी तो एक 95 परसेंटाइल के ऊपर और 5 परसेंटाइल के नीचे होगा, राइट?
हाँ.
तो नए केस में वो आउटलायर्स बन जाएंगे, बट दोज आर नॉट रियली आउटलायर्स. क्लियर है?
ओके ओके. एंड हियर इन
आउटलायर्स हटाए.
अच्छा, और क्लस्टरिंग में हम ट्रेन और टेस्ट नहीं डिवाइड करते हैं.
हाँ, डज नॉट मेक सेंस.
ओके.
मतलब अगर आप कर भी दोगे तो इट विल नॉट मेक सेंस. क्योंकि देखो, ट्रेन और टेस्ट क्यों नहीं है? क्योंकि हम एक्यूरेसी तो चेक कर ही नहीं सकते ना. वी डोंट नो विच वन बिलोंग्स टू विच क्लस्टर इन रियलिटी. अनसुपरवाइज्ड मशीन लर्निंग है, रिमेंबर?
Yeah, so there's nothing to compare.
Yes, there is no performance measure here. That is why there is no train test split. Okay. Any other questions, guys?
Sir, ROC curve में if I have more than 2 classification, तो ROC curve नहीं बनेगा ना? नहीं
बनता है.
हाँ.
There are strategies. आप true positive rate सारे categories का ऐड कर दीजिए and false positive rate सारे categories का ऐड कर दीजिए.
अच्छा.
ठीक है, तो वो मतलब हो जाता है अगर आप चाहोगे तो, बट उसका मतलब रेलेवेंस उतना ज्यादा नहीं होता है. बिकॉज मान लो कि आपका ट्रू पॉजिटिव रेट जब बढ़ रहा है, फॉल्स नेगेटिव रेट अगर सिर्फ एक ही में बढ़ रहा है, बाकियों में नहीं बढ़ रहा है, तो इन सर्टेन केसेस दैट माइट बी फाइन. जैसे ही आप सम इंट्रोड्यूस कर देते हो ना कोई भी चीज में, लाइक जब आपके पास बुलियन वैल्यू है 0 और 1, तो या तो वो 0 है या तो वो 1 है. बट अब अगर 0, 1 और 2 है, तो 0 को आप पॉजिटिव ले रहे हो, 1 और 2 को आप अगर नेगेटिव ले रहे हो, तो 1 बढ़ रहा है या 2 बढ़ रहा है, दैट यू विल नेवर नो. यू डोंट नो इफ दे आर मूविंग यूनिफॉर्मली और दे आर मूविंग डिस्प्रोपोर्शनेटली.
Correct. And sir, one more thing. I was analyzing this loan on a loan data set. तो उसमें जो लोन अमाउंट का जो कॉलम है उसमें जब मैंने आउटलायर्स देखे, so obviously there were few outliers. But when I actually studied the data, so the loan amount was increasing with the amount of months. तो जितना months बढ़ता है उतना loan amount बढ़ रहा है. So
Yes.
should I actually consider them as outliers? Because when I
No.
calculated that above 75%, no ना?
नहीं, तो उसमें हम क्या करते हैं ना, लाइक देखो, दैट इज व्हाई आई सेड डोमेन अंडरस्टैंडिंग इंपॉर्टेंट क्या है, बिकॉज यू विल नॉर्मलाइज लोन अमाउंट बाय टेन्योर, राइट. तो आप ना पर मंथ लोन देखो. टेन्योर से अगर आप देखोगे ना, लाइक यू हैव अ 50 lakhs लोन, राइट. इफ इट इज ओवर द पीरियड ऑफ 50 years, देन इट्स अ वेरी गुड लोन. पर ईयर आपको 1 lakh आसपास, आई मीन नॉट गोइंग इनटू द टेक्निकलिटीज, बट इफ यू हैव लाइक अ 50 lakhs लोन and that is in 1 year, then it's a very big loan, right. तो point being, आप 50 lakhs को डिवाइड बाय इयर्स करोगे ना, 50 years, तो ये आपका 1 आ जाएगा. और ये 50 lakhs को आप डिवाइड बाय 1 year करोगे तो ये 50 आ जाएगा. अब आप आउटलायर कंपेयर करो 1 और 50 में. क्लियर है?
ओके. तो
फॉर
पहले
एग्जाम्पल,
नॉर्मलाइज.
अगर आप कोई प्रोडक्ट का प्राइस देखते हो, सिर्फ प्राइस देखते हो 10,000, बट अगर आप देखते हो कि उसका क्वांटिटी भी है एंड क्वांटिटी इज लाइक 20, तो आपका प्रैक्टिकल प्राइस पर प्रोडक्ट में आपको आउटलायर निकालना है. सिर्फ प्राइस पे आप आउटलायर नहीं निकाल सकते.
Right. Yeah. So I shouldn't remove the outliers.
You should remove the outliers, but you should calculate outliers correctly.
Okay. Like I should first standardize it or something and then.
या तो लॉजिकल स्टैंडर्डाइजेशन भी होता है, डेटा स्टैंडर्डाइजेशन भी होता है. जो आप बोल रहे हो वो लॉजिकल स्टैंडर्डाइजेशन है, क्योंकि आपको डेटा के बारे में पता है.
राइट. ओके सर, थैंक यू.
ठीक है. इसका एक और आइडिया आप ले सकते हो कि टाइटैनिक डेटा सेट में जो फेयर वाला कॉलम था ना, अगर नंबर ऑफ पैसेंजर्स 4 हैं इन दैट सेम टिकट, तो ऑब्वियसली फेयर ज्यादा होगा. तो वो फेयर आउटलायर नहीं है. फेयर पर पैसेंजर से आप आउटलायर निकालोगे, नॉट जस्ट फेयर. ओके.
या तो सर मुझे एक सेपरेट कॉलम बनाना पड़ेगा.
यस.
और वो पर कॉलम का मुझे फिर आउटलायर निकालना पड़ेगा.
यस. और उसके बेसिस पे आप रोज हटाओगे जहां पे वो नया कॉलम आउटलायर.
अच्छा. ओके.
ठीक है गाइस, सो आई हैव अपलोडेड द क्लस्टरिंग नोटबुक. ठीक है. टुमारो आई विल फर्स्ट आंसर एनी डाउट्स और क्वेश्चंस दैट यू गाइस हैव, देन वी विल मूव टू टाइम सीरीज मॉडलिंग. ओके. टाइम सीरीज वाला कल जो नोटबुक है, दिस इज द नोटबुक दैट वी आर गोइंग टू कवर. टाइम सीरीज का कोर चैलेंजेस डिस्कस करेंगे, कोर प्रॉब्लम्स, we'll understand how to handle things, the different kinds of models, etc, and that will be wrapping up our Python predictive modeling batch. ठीक है. तो कल ये बैच खत्म हो जाएगा and I'll make sure कि कल खत्म हो जाए. if we need extra 10-15 minutes, तो I'll pull the class little bit, but I don't want to delay another week. ठीक है. because then you guys can actually revise, go through, do some own work, case study, projects and वो सब आ सकता है. तो tomorrow we'll cover time series modeling. And first I'll answer any questions you have for any doubts of clustering and regression, logistic regression, which is classification. Okay. Great. Any questions? Okay, great. Thanks everyone. Have a good day. I'll see you all tomorrow. Bye bye.